Hello, guys, and thank you for joining in today's session. And thank you, Mr. Nakhil, for this comprehensive introduction. In today's session, we are going to take a look at Python and how it's actually the tool for the future. This session is going to be in two parts today. So the first part, I'm going to show you some slides, and the second part is going to be the code that I'm going to show you. So without further ado, let's go ahead and start the session. A brief introduction about the instructor about me. I have been working in the oil and gas industry for more than 12 years. I specialized in production and flow assurance engineering, as well as I am a domain data science. I have trained more than 800 engineers, specialists on the topics of Python, data science, and artificial intelligence. Plus, I have a comprehensive experience in .NET, C# development, databases, SQL, Python, and other web technologies. Plus, I do have core knowledge in OFM, PipeSim, IPM, Olga, and other oil and gas industry standard tools. Plus, I specialize in creating workflows for upstream engineering that basically targets automation and engineering calculations. So, the first question that comes into mind whenever we hear about Python: why Python? What's the catch? So if you were in the working in the 2000s and mid 2000s and sometimes at the end of the 90s, those era were about commercial softwares and using ready to use solutions. And virtually programming languages were not welcome in that era. But nowadays you can hear that Python is being used everywhere in the oil and gas industry. So I will try to break down why Python is so important nowadays in oil and gas industry. Number one, it's simple, powerful, and it's widely used across industries. So this means that if you learn Python well in the oil and gas industry, you can transfer easily to other industries and utilize the same knowledges that you have earned. Number two, Python is considered the Excel of the future. So back then or still today, Excel is being used for virtually everything, and Python is going to be also similar to that. Although in this training we don't encourage the replacement of Excel, we rather encourage the integration alongside with Excel to skyrocket the analysis and the productivity. Plus, there is an upward-looking trend where the industry is shifting towards data-driven technologies and making decisions using machine learning and AI. Unfortunately, this is not possible unless you have the proper knowledge in Python. There are some tools that basically are known as no-code softwares that basically allow you to do machine learning and artificial intelligence workflows. But these softwares, at best, can be considered limited. And even inside those softwares, you will find a place where you can inject some Python code to do some sort of advanced workflows with these softwares. The more important thing or the most important thing that Python offers is actually it's very easy to learn. This is under one condition, that is you're learning the Python the right way. Otherwise, you're going to waste a lot of time. But generally, the syntax is easy. It's easy to grab. Plus, the learning curve is not that hard. For engineers, it's very going to be intuitive somewhat. Plus, Python offers all data science tools that you can imagine and think of. And I am talking about tools to read files, tools to get data from complex data files, structure those files, and extract data, explore those data, create some complex calculations, and visualize and create the reportings. All of these are possible in Python. Not just these tools are available, also there are tools that are alternative to these. So if you use a particular tool in Python, what you will see, that like there is multiple tools they can do the same thing, which is a very healthy thing in Python, where you can have like multiple things that can achieve the same thing, so you have much more options to select from. Plus, Python allows us to integrate more data sources together. So basically, this allows us to create a more massive application and a more generalized application to our workflows. Python can deal with access files, Excel files, text files, tab files, ASCII files, uh, digital log files, even with Words, PDF, PowerPoints. All of these are possible to pull into Python and basically do your manipulation. One of the most important things that you can achieve in Python is automate workflows. So if you have like a boring workflow, if you have like a workflow that's repetitive, it's taking too much time. Basically, it's like taking lots of times of your hand, and basically you're not doing only minimal analysis because of organizing data. You can write a code and you can repeat running that code forever. It will basically start organizing your data, and you will have much more free time to turn to. Actually, Python is being used in oil and gas industry to address industry challenges that we already have. And one of those challenges is actually the large volumes of data we have been getting. So basically back in 2019, in mid 90s and mid 2000s, we did not have that much data. We did have data, but it was not that much. Nowadays, it's customary to have like thousand upon thousand of log files, thousand upon thousand of production files, drilling reports, workover reports, daily reports, you can name it. So all of these files makes managing these files, and basically the more important thing, extracting insights and decisions from these files are really hard to do. But with the help of Python, this can be a little bit easier to do because Python offers like really large selection of tools that allows you to do that. The having the overload of data or too much data, it's basically it creates a situation where you don't have enough time to analyze multiple assets. Plus the assets are growing with time, so the number of assets are getting larger and larger as we move progress in time. So that's why if you use Python as a tool to help you, it will allow you to analyze or at least do some autopilot in analysis on some of these. And the final thing that you can do is just QC these and basically approve or not approve these analysis. So Python can actually automate these things for you. The most important thing that Python came to use is the need to create predictive models to optimize production or to optimize anything we want or even create petrophysical interpretations. So no matter what you did, usually if you go to the website One Petro, so in One Petro you will find papers that basically talking about how to utilize machine learning, how to do artificial intelligence on this topic, on that topic. So basically, all of these things are basically based on Python. Python can also allow you to do advanced visualization like contour maps, like heat maps, GIS maps, and all of these advanced maps that usually we find either in commercial tools or we lack in free tools. One of the important things that you should actually use Python for is the ability to be integrated with Excel, Pipesym, Prosper, Gap, and other engineering tools. This is an extremely important thing, by the way. So, what you will learn if you joined this training, you will learn lots of things, but I can guarantee you, at least you'll learn these minimal things. So, number one, you will have a solid understanding and solid skill in problem solving whenever it's related to workflows in the oil and gas industry. You will build a really strong foundation of how to handle and manipulate multiple data and data sources at the same time. You will have the skill to solve problems that are going to be encountered in the workplace environment. Plus, we're going to expose you to large number of libraries that are basically supported in Python and used for workflows. Plus, we are going to show you how these libraries can have tangible results in your day-to-day work with Python. We are going to also show you how workflows can be done in oil and gas industry. So oil and gas industry workflows requires first-hand experience on this. Um, each example, each tutorial, each mini project that we usually do in this 8 weeks long training. It's all designed from scratch. You're not going to find these online. You're not going to find these anywhere because we are designing everything from ground up. Plus, we will show you how to control the data flow, how to do calculations, how basically to drive insights from your data, and how we can also we'll show you how to implement empirical methods and diagnostics method that we use in oil and gas industry in commercial softwares, and how we can transition those into OFM. Sorry, in Python. Python can have also great impact in your on your career if you learn this properly. It will open a wide range of career improvement for you. It allows you to automate projects using pipes and Prosper and Gap and other softwares. It allows you to create petrophysical analysis for free without having like any softwares. This is all possible with a library called Lasio, which is a very powerful library. Plus, it allows you to create dashboards, manage data, connect to SQL, connect to Access files, create visualization aids, and basically you can do lots and lots of things with this. You can create reservoir monitoring applications. You can do the same thing for drilling, production, and whatnot. Plus, but the more important thing, Python is one stop for multiple data sources. So you don't need to install, for example, other languages or other tools in order to read different data sources. Most probably 99% of the data sources can be read through Python. So here is a snapshot of what our participants think of or the previous trainings they had. So basically this is going to be the fourth iteration of this training. So each year we have a single batch. Usually the batch is ranging from 30 to 50 participants. And this is what our participants think. Please make sure to take a screenshot or snapshot of this and then go through these things if you're interested in this. Now we are going to start with the second part where we'll discuss Python as a tool. So if we take a look at the Python, we will see that Python was created in 1991. So Python is neither a new language nor it's an old language. It's something in between. Python has evolved so much from the 90s. Nowadays, we have basically virtually a library or a tool that allows or help us to do something for some domain. And basically, the number of tools that are expected to be in Python, it's around like 100,000. So no one knows the exact count, but the tools are just too much to wrap our head around it. I will show you like the basic uses of Python in this slide. There is no way to have like all the possible uses of Python because Python is so diverse. People are getting very creative with Python. They are using it for virtually everything. One thing that you find Python is being heavily involved nowadays is the web development. So if you look through your Facebook app and Instagram app, usually there are some types of ads and suggestions or friend suggestions or connection suggestions that you will see in these applications. Most probably this is done using Python inside these servers of these softwares. People also use this for software development. People use Python to create full-fledged software. A famous example in oil and gas industry is the Techlog, where it's based on Python technology. Techlog by SLB, where this is basically it's used for petrophysical analysis. People also use a Python for academia for mathematics. So instead of Matlab, so it's a great free choice. So this is a Matlab alternative with the proper libraries used. You can use Python for system scripting. System scripting is where something you will do something to tell Windows what to do at a particular time. So it's very similar to Windows scheduler, but it's going to be much more powerful than that. You can do, for example, you can allow Windows to do, for example, a particular thing or a particular task at a particular time each day until it reaches a certain endpoint. So once you do this, this allows you to create automations and basically send reports at 6 a.m. to people, maybe do some calculations at a particular time. This is all possible using system scripting. The most important thing in Python, people use it like 80% of Python usages is in this area. It's actually data science. We have lots and lots of people using Python for data science. Data science is basically anything to do with the data processing, reading, formatting, calculation, visualization, and driving insights from the data. This is all related to data science. And probably data science is one of the largest community on the internet. They have lots and lots and lots of tools for data science, different visualization aids. I think we have like something more than 100 types of visualizations that we can do in the data science. So that's why people love using Python for data science because it has everything they need. Usually, whenever, if you think that writing the code is much more harder than using an application with clickers and buttons, but let me tell you one thing. It's true that the graphical user interface, it's easier to do, but once you write the code, you will have the code. You can run the code forever, while the clickers and the things that you do in the interface, it's going to be lost. It's not going to be saved anywhere. But this does not mean we have always to write the code in order to use Python. We can also create graphical user interfaces with Python, and the graphical interfaces are very modern and they are very friendly and intuitive. Plus, we can also see people using Python for engineering design and computation. So this is basically for computational fluid dynamics, where it's a part of mechanical engineering, where this is basically used to calculate the flow and basically the performance of certain equipments like automobiles, like engines, like valves, pipelines, vessels. So some of these are also designed in Python because Python provides a free interface to these types of calculations. Now, if we take a look, why has Python become so popular in basically in all industries, not oil and gas industries? But we are actually specifically talking about oil and gas industry, so we will make this slide a little bit more customized. So the sheer number of libraries in Python actually allow us to use Python quite often because what a library is something that someone wrote and you're basically just using it. For example, if you want to read Excel in Python or if you want to create a visualization in Python, this is just a single line of code. While if you do this manually, I think it's going to take somewhere between like 100 lines up to 1,000 lines. So that's why we use library. It's a shortcut of the time. It allows you to do powerful things in a short amount of time with little amount of code. Plus, Python have a big community and a huge support. We have more than millions of programmers that basically are using Python. Those are across all the industries. So probably if you have like a certain problem in Python in the future, if you post that online, the problem, if you post it online, most probably you're going to see multiple solutions to that problem. Why this is happening? Because Python has a big community and a huge support. So if for some tool is being used a lot, then lots of errors will be captured and it will be solved. If you use, for example, a tool that's very obscure, no one uses, well, if you for example, if you face the problem at a certain time, most probably you're going to solve this, but it's going to take too much time. With Python, this does not exist because all the problems we have for the Python, usually there is a solution to it online. Plus, Python is free. It's easy to learn. We already said that this is under the condition you start the right path. Plus, it's easy to share the code. Python code, it's going to run the same on Windows, it's going to run the same on macOS, on Linux, or Unix, or any system of your choice. So that's why in the training we usually have people who have Mac OS joining the training, people who have Linux OS joining the training, or sorry, the GNU Linux. We have lots of people from with different backgrounds and different computer capabilities joining in. So basically, they paste the same code we send them, and basically the code just works as is. Plus, the most important thing for us as oil and gas people, Python offers large selection libraries of oil and gas things. For example, if you want to do multi-phase calculation, that's already existing in Python. If you want to do PVT calculation, that library also exists in Python, and so on and so forth. Python is known actually for its ease of use, which is one of the previous points that we discussed. I have in front of you three pieces of code. We have the Python code, we have a C sharp code. So let's just label those as 1, 2, 3. So just take a look at these three codes. Okay, and determine which one is easier to read and hence it's easier to write. I'll give you like a half a minute to just take a look at these three codes. You will find that Python is clearly the easier one to read, plus it's the easier one that resembles the English-like language. And if the C sharp code, you'll find more lines are involved, more data types are declared. The same thing goes for the Rust. It's worse actually than C sharp. You need to also determine the size of these variables as well. By the way, Rust is not being used in oil and gas industry. It's actually a relatively new language, but C sharp is being used for software development in really large companies. But you can see why Python is the choice of engineers and scientists alike because it's easy to write, it's easy to read, and basically it's more productive this way. Usually, we write the programming languages in something known as IDE. IDE is short for Integrated Development Environment. So, what is an integrated development environment? It's a piece of software that allows you to write a code. Okay, so it's just like, for example, whenever you're working with data, you usually use Excel. So you can think of IDE as the Excel of Python or other programming languages. Actually, the good thing about Python is actually you're not restricted to using just one IDE. You can use any IDE you want, or you can use any software to do the development you want. We have lots of familiar options. We have Spider we can use. We have PyCharm. We have Visual Studio Code. Actually, we have like new tools already arriving, like Marimo. We have other tools like Positron. So all of these tools are free to use, and basically, it's going to be like this forever. Now let's see what software companies are basically using Python to integrate it with their tools. We have the famous tool TechLog. It's already built on Python. As we mentioned earlier, we have Olga from SLB, where you can intercept Olga results and basically pull those into Python using few methods, or actually using multiple methods. And once you do that, you can create your custom calculations. You can create like how much volumes of fluid you're getting from it, and so on and so forth. You can also connect to PipeSim. PipeSim started to offer Python integration from 2017 and onwards. Before that, we did not have like any integrations, but after the 2017, you can connect PipeSim to Python and do model management, simulation management. Basically, you can do lots and lots of optimization scenarios with this. Same thing goes for the IPM or the Prosper and Gap software. So you can use the Gap and the Prosper alongside with Python. So let's say if you have like a network with hundreds of wells, and it's a very daunting task to start managing those. What we can do is we can connect Gap to Pipesym, Gap to Python, and once we do the connection, we can actually pull data from Excel and then push it to Gap to update all of these nodes and all of these boundaries, which are represented by wells, facilities, and whatnot. So all of these are possible. Same thing goes for geolog, and also we have a T-Navigator, which is a relatively newer reservoir simulation tool by RFD company. So this T Navigator, what it can do, it can you can inject custom Python codes in it. Plus, it shows you like typical simulation task that can be controlled using Python. Basically, this software is whenever you open a particular functionality in this software, you can edit that functionality by using Python. And you can see Python is nowadays being used everywhere. Here is a few list or a very small list of the libraries that are available in Python that can be used for oil and gas industry. But this is not just a small list. It's a very comprehensive list of what you can find online. Actually, there are like 10 times X or 20 times X these amounts of libraries online you can find with different purposes. We have, for example, a library called Lasio. We read this to read digital log files. We have a library called Fluids. You can do multi-phase flow calculations with it. We have a library for VLP correlation calculations using, for example, HDOR and Big Brill. We have a path of visualization file. This is specifically for drilling engineering. Plus, we have another a library that also can calculate the well path. This is going to be directional or horizontal well. We have libraries to do PVT calculations like CoolProp. Actually, where we don't just have one library, we have multiple libraries to do this thing, which is the CoolProp thing. We have libraries to visualize the port throats and the port connections. So this is going to be a communication between port visualizations, just like this. So plus it has like statistical distribution for all of these. This is basically resembling of what you will have typically in a core plug. So you can use this to visualize that and simulate, of course. And we have also libraries that support you mechanical calculation and rock property calculations. Now, do you see all of these pictures and all of these charts? These are basically examples from the previous training. Usually, we do lots and lots of examples. We provide our trainees with many, many examples to be covered. Each example is covering a particular task in oil and gas industry. We also take hints from our participants. We take considerations, and basically we convert participants' uh, requests into actual examples that we usually see. Let's say we usually realize in the training. So these are all the examples that we have done in the previous batches. So this concludes the first part of the session, which was using Python for oil and gas industry and all of the theory and all of the slides behind it. Now we are going to start working with the Python code. Okay, so this is going to be the fun part where you will see like Python in action. You will understand why Python is being used the way it is in oil and gas industry. So let me open a file that we're going to work with today. Now, the black screen that you see in front of you is actually, this is where we are going to write the code. Now we have these two files. We have the monthly production file, where basically this shows like the monthly production of a particular multiple assets. And we have also the section head, or let's say the X and Y of these files. So what we can do is we will try from now on until we conclude today's session, we will try to, let's say, do as many analysis as possible. Okay, so the first thing that I am going to read is the uh, the the header files or the section head files. So I am going to go right click and you see these are Excel files. So right click and then go to copy path. What I'm going to do is I'm going to import pandas. So import pandas. Pandas will help us to read those files. We're going to import Plotly. Plotly will help us to actually visualize these data. Once we have these, what we can do is we can actually start reading those files. So I will create a variable called section head where I am going to read those things. So header equals to read Excel. So using this function, we can read Excel. We're just going to paste this file afterwards. And what we are going to do is we are going to have uh, the sheet name. We're going to target a sheet name called joined. Okay, so once we do this, we can do header. So we can visualize what's happening in the calculation. Actually, this is a misspelled. So we have an E. Run this. There we go. Now we have, this is our file. Let's set up the view to be a column view. So once we have these, what we can do is now we can start pulling the monthly data as well. So let me show you how we can get the monthly data. So month equals to pandas read Excel. So we're going to read Excel and we're going to do the same thing. We're just going to paste the file and we're going to only change the name of the file and we're going to do month. Once we do month, you will see that monthly data now started to show. This is where we are visualizing the files. Let me show you where now we can utilize these data. Okay, so we will move right hand side. Once we move right hand side, what we can do now, we can start creating like basic visualizations, and then we will be progressing towards a little bit more complex visualizations. So if I am trying to create a base map based on the uh, like the locations of the wells and basically do some analysis on this, I'm going to create a scatter plot, and in this scatter plot, I'm going to feed it the header data, and X data is going to be the X containing data, which is going to be the wellhead location, easting, and for the y-axis, we're going to have the same thing, wellhead locations in feet for north. And if we run this, actually we are missing a T. So if we type a T, run this, this should show you the results. There we go. Now these are the locations of the wells. And what we can do is now we can actually have more context on this. Okay, so we can activate an option and call it that we want to pull the well name and then assign it to the names of the wells. So your wells are going to look like this. Now you have a little bit more context on this. Plus, there is one thing that you can do. Uh, Depending on the data you have, you can assign different properties to your data. For example, or to your data points. For example, these wells we can have those wells as like for example slanted wells. We can show these as slanted or vertical wells, directional. We can do that. We can also show like the type of the well and the well status. So we can actually color those wells based on these criteria. So let's do one thing. So I'll show you one example where I am basically showing the well status alongside where let's say uh, it's directional or not. So we will say that color equals to well. Let's do a well status with this. Let's get the correct column name. So it's this thing. There we go. Now you have the blue ones are producing, the red ones are injection. So what you can do, and so on, you can just double click on any of these and basically select off that. And this is going to be highly interactive. Plus, you can zoom into any portion of the cross section, or let's say the top section, and you can do lots of interactions with this. So what I'm going to do is I'm going to copy and paste the code that generated this for me, and then I'm going to create a new Python file code. And in this Python code, there is one thing that I'm going to do. I am going to also change, let's say, the sizes of these dots. So far, this is a dot map or a base map. What I can do is I can reflect how much water is each well is making. So this is by controlling the size of these bubbles. Okay, so how can we do this? We will do something like size equals to barrels of water that's being produced by these wells. So now this is going to show you an idea of how these wells are actually affected by water production. So this is just another example. So let me show you one more example. We can do the same thing. We can copy the code and let's open another column. So in this column, what we're going to do is we're going to do the same thing, but I am going to keep the size for water, but I'm not going to color based on the well status. I am going to use the amount of um, oil that's being yield from this field. So this will give me a clear understanding of how different parameters are working together. So this is going to be, of course, a multi-parameter thing. So barrels of oil or condensate. So this is the name of the column that's responsible for it. There we go. Now the lighter the column, the let's say the more fluid produced you have, and the lower the, or let's say the darker the column or the darker the colors, the low oil you have. Okay, so you can clearly see like the wells on the left-hand side are more producing. What we can do is we can also select one of these wells. We don't have to, by the way, we don't have to select all the wells. What we can do is, in order to see what available wells we have, we can say, for example, we can say header dot well name dot unique. So basically, we're going to retrieve only unique well names. So these are the well names that are available. What we're going to do, we're going to select this Catherine well, this one. Let's look for it. This one, Catherine Hawkins. So what I can do is I can basically create a filter around this, by the way. So let's copy that and let's do a filter for this well. We can select off just one well, by the way. So we will set it. For example, let's call this my well equals to Catherine well. Okay, so let's move forward to another example. In this example, I'm going to show you how we can create a bar chart where you basically compare multiple wells together. So this is going to be Plotly Express dot bar chart, and we're going to feed the same data, which is the header. So the x-axis is going to be actually the well name, and the y-axis for this is going to be the let's say the variables that we're in concern. Let's say we are looking for barrels of water that's yielded. Let's run this. So this is basically the chart that you get for the for these wells. There is one thing that you can do if you want to sort these wells by like the highest value to the lowest value. We need to create a new table around that, or filter that table out, sort it out. So this is going to be something like this. Let's call this sorted, or let's call this sort equals to header dot sort underscore values. And we will say that we want to sort this based on, let's say, barrels of water yielded. And of course, we can say that ascending equals to full. So basically, we want this in a descending order. We will just change out the data, and then we're going to get something like this. Now, this was one more analysis. Let me show you how we can now start working with the monthly data, because the monthly data is going to be like the ones that contains lots of analysis we can do. Let's open a fourth column. So let me show you a very simple way to create a line chart and basically do some interactive analysis with that. So if we do Plotly Express line and feed the monthly to it, the x-axis are going to be the RPT date. So this is going to be the date. The y-axis is going to be anything you want. For examples, let's take a look at barrels of oil or condensate. Run this. There we go. Now this is the full production history for these monthly data for these wells. The problem with is now each well is actually is interfering with the other wells because each well has like a same color like the other ones. If you want to bypass this, what we can do is we can start basically coloring these based on the name of the well. So once we do this, we will get a little bit better distinguish between the wells. What we can do is, of course, we can even maximize the results of this. Basically, we can visualize this and in a better way. You can double click on any well you want, by the way, just like this, and yeah, select off anything you want, and you can just this can be just like the basis of comparison. Of course, you can zoom into any time and date and compare those as well. Okay, so now let's move to another example where I am going to show you like how we can convert this into an area chart. So if we copy this and paste it below and just swap up the line for area, this should give you a really nice looking area chart. Basically, this shows you like the total production from each wells, like on in monthly values. One final thing we can do is we can take, for example, one of those wells. For example, let's get like the list of the wells again, or we already have those what we can do is we can select like one of these. Let's select this one. Let's select this well, the Hoken well. So let's select the K Hoken well. So what we can do is we can create a filter around this well, and then we generate a new results for this. So we can say that Hoken equals to the original table, which is this one, and then basically we're going to filter the well name based on the well that we have selected. By the way, this can be also interactive. You can select any well you want interactively. Once you do this, what you can do is you can start visualizing this for just this one well. So let's do this as a scatter chart. This is going to be another chart. So it's going to be the Hoken thing, and x-axis is going to be the date, and the y-axis is going to be anything you want. For example, let's do oil in this situation as well. So we will copy the paste the oil thing and set it to the y-axis, and this should show you a scatter chart. Now, one thing, if the production is very erratic on any of these wells, what we can do is we can create a moving average and calculate a moving average that's passing through these lines. So this is easily possible uh, by creating a, uh, a column for the moving average. So let's call this moving average equals to, so the column that contains the oil, so oil dot rolling. So this will create a rolling window for us. So let's say that we're looking for 10 points average at the same time, and then we're going to calculate the mean of these 10 points. By the way, you can repeat this as many times as you want to get this thing as smooth as possible. For example, let's say this is moving average of 10. Let's do another moving average of 15. So the more moving averages you include, the more smoother your line will be. Now, how can we reflect these calculations on the chart itself? What we can do is we can add those as uh, second and third curves like this. So let's include MA15 and MA10 alongside with this and run this. There we go. Now you can see the moving average is also showing up. What you can do is you can convert this from scatter to line chart, or you can actually mix and match between those. There we go. Now you can see that you got one original curve and two smoothing curves. Last thing we can do is we can actually visualize the data that is basically the outcomes of this calculation. So if we do like Hoken, just press on enter, it will basically show you like all the calculations, including the moving average 10 and moving average 15. So we can basically browse to any page we want. You can see the calculated moving average values against the original values. This is all from my side. Thank you so much for joining in. Now over to you, Nikhil, and hopefully you have learned new things. Now we are going to start answering some of the questions that popped up in the chat box. Thank you so much, and see you in the next session.